Hey everyone, welcome back to my channel. Today we are going to be doing our 7th video in the LeetCode 75 study plan series. So this problem is called product of array except self, and it's ranked as medium difficulty. So let's go ahead and look at the problem statement. So given an integer array nums, return an array answer such that answer I is equal to the product of all elements of nums except nums at index I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time and without using the division operation. So the first time that I went through this problem, I was kind of just dove right into it and didn't pay attention to having to write it in big O of n times. So I did a brute force solution, which basically had a nested loop, and then I used a temporary integer to take out. I basically assigned the current uh, number at index I to 1 so that it wouldn't affect it wouldn't affect the product that was going to be, at the specific index for the answer array. Um, and other people have said there's a brute force solution where you can actually just divide out the number 2, but that doesn't meet the constraint for this problem, and it also would fail if the number was 0 because it wouldn't work properly. So we're going to figure out a big O of n solution, which I have for you today, which basically we're going to be solving basically uh, the products, the answer to the left of the index in the array and to the right, and then we basically combine those answers, and then that's going to give our final result. So let's go ahead and dive right into the code implementation, so I can show you guys what I'm talking about. So first, in order to make things easy, let's just declare an integer length, because we're going to need to use this several times. So instead of just using nums.length several times, this is faster. Okay, and then we want to put together our answer array. So we'll do that, new int, and then this is just going to be length. All right, and then now we want to consider two cases, right? There's going to be, for the first index at 0, there's nothing to the left of 0, and then same for the last index, there's nothing to the right of it. So we have to consider that as 1, because 1 isn't going to affect the outcome of the product, right? If you multiply something by 1, it just remains the same. So we'll put answer at index 0 is equal to 1. All right, and then we want to do a for loop where we're setting I equal to 1 because we're going to be checking to the left of 1. Okay, and then length, and then we'll just iterate through I, standard for loop. Okay, and then what we're doing here is we're finding like I mentioned earlier, we're finding the answers for the left side. So we'll do answer at I is equal to nums I minus 1 times answer I minus 1. Right? Okay, and then now we have to do it for the right, and so we can call this R for right, and we'll do this equal to 1. Okay, so int I equals length minus 1. So the reason I'm doing minus 1 is because we're actually going to be going from the right and then iterating down towards 0. And that's how we're going to solve things for the right side. Okay, and then we'll do it till I is greater than or equal to 0, and then I minus minus. It's basically just the opposite of what we did above. Okay, and then answer at I, and then in order to save some time, we can use the shorthand multiplication an equal sign. Instead of doing answer times I, or answer at index I times R, we can just do times equal and then R. And then we have to adjust R, right? So R is equal to nums at I. All right. And then all we have to do is return our answer and cross our fingers. Right. Okay, cool. So this works, and this has a time complexity of big O of n and a space complexity of big O of 1, constant space complexity, just because uh, the answer array, you might be thinking, oh, it has big O of n for the space complexity, but they specified that for the answer array, it doesn't actually count. So we're going to be saying that for the space complexity, it's big O of 1. And then I'll just for the heck of it, I'll show you guys my first attempt at this problem. So it failed. It got like 18 out of 22 test cases, and the reason that it didn't pass one of the test cases is not because it doesn't work logically. It's because it wasn't fast enough. Because this is a big O of n times 2. It's an exponential time complexity. So what I did here is I just had a nested for loop, and then I had a temporary integer where I basically just set it to 1, and then I calculated it and then returned that. So that was kind of like the naive approach, but this is the most efficient answer, and this is what's going to help you get past a good result in your if you have this pop up in one of your interviews. So I hope this was helpful. And if you enjoyed the video, please go ahead and leave a like and subscribe. I'm still trying to build up my channel, so any new subscribers are greatly appreciated. And if you have any suggestions for other videos or any comments, any questions, feel free to leave that in the comment section. And I'll see you all in the next video.